Alright guys, this video is about the strong acid, strong base, and weak acid and weak base. In addition, we're going to review what we learned about acidic and basic solutions, including pH value and some calculations. Now let's take a look at what how we identify the strong acid and strong base and weak acid and weak base. For strong acid or strong base, when you dissolve them in water, you get 100% dissociation. But if you dissolve weak acid or weak base in water, you only get partial dissociation. Think about it. Let's use the hydrochloric acid as an example. If you dissolve hydrochloric acid in water, okay, you will get hydronium cation and chloride. And if you do experiments, you will find out that all of the hydrochloric acid molecule will dissociate. There is no hydrochloric acid molecule left at all. So we use a one-way arrow to indicate that this is 100% dissociation and the hydrochloric acid is a strong acid. But if you have a very weak acid, for instance, hydrogen fluoride, if you dissolve that in water, you will find out that only part of this hydrofluoride molecule will dissociate to give you hydronium cation and fluoride. Okay, you still have hydrofluoride molecules left, okay, in this solution. So in order to distinguish the strong acid and weak acid, for weak acid we use this two-way arrow to indicate that you will establish an equilibrium state once you dissolve the weak acid in water. Alright, so this is the difference between a strong acid, strong base, and weak acid and weak base. Here, these two tables shows you some typical strong acid and strong bases. And I need you to remember this for strong acid: perchloric acid, hydrochloric acid, sulfuric acid, and nitric acid. And these are the conjugate base of these four acids. Okay, again, 100% dissociation. Strong bases, these are six typical strong bases, and as you can see from this table, these three strong bases, the cations are from group 1. These three strong bases, the cations are from group 2. So if you have bases, okay, and if the cations are from the group 1 and group 2, then most likely they are strong bases. Once you remember this typical strong acid and strong bases, the other acid and the bases, most likely they are weak acid and weak bases. Okay, so this is a strong acid, strong base, and weak acid and weak base. Now let's take a look at the acidic and basic solutions, how we define them. And this is a concept map we constructed during our lecture. And we started from the self-dissociation of water, okay, and then we established that the Kw, which is the equilibrium constant of water, and we said that because of the concentrations of hydronium and hydroxide are 10 to the negative 7 mole per liter, the equilibrium constant Kw for water is 10 to the negative 14. And based on that, we talked about how we calculate the hydronium concentration, okay, and the hydroxide concentration. And then we talked about how we define the pH value and the pOH value. And then we talked about how we connect the pH value and the pOH value together. The sum of pH value and pOH value equals to 14. No matter what kind of aqueous solution you are talking about, either acidic or basic, you always have this kind of relationship between the pH and pOH value. And then how do we define whether a solution is acidic or basic or neutral? Then you have to take a look at the pH value. If pH value is 7, neutral solution. If pH value is less than 7, acidic. If pH value is higher than 7, it's basic. Okay, so this is a concept map we constructed. Now let's do some practice. I have a table here for you to take a look. Okay, and in this table, I ask you to calculate the pOH value, hydronium concentration, and OH concentration if you know the pH value of this solution. And I want you to identify whether this solution is acidic or basic. Okay, and let's work on this first one. You know the pH value is 4.75. Then how do we find out the pOH value? You use this equation. Okay, so pOH equals to 14 minus pH value. So that is 14 minus 4.75, and that is 9.25. All right? How do we find out the hydronium concentration? Remember, pH value is defined as the negative logarithm of hydronium concentration. You know pH value already. You just need to find out the hydronium concentration based on this equation. So here is the setup. 4.75 equals to negative logarithm of hydronium concentration. Okay, so this is a starting point of our calculation. How do we get rid of this logarithm sign? Let me show you. I multiply negative 1 on the two sides, so you have negative 4.75 equals to negative, it's positive logarithm of hydronium concentration. All right, so now remember how we get rid of logarithm sign? You raise the two sides to the exponent position of 10. We are talking about the normal logarithm here, so the base is 10. So 10 to the negative 4.75 equals to the concentration of hydronium. Sorry, this is not 4. This is plus sign. Okay, so it equals to 1.78. So the hydronium concentration, okay, equals to 1.78 times 10 to the negative 5 mole per liter. This is how we find out the hydronium concentration. Now, hydroxide concentration, there are two ways to find it. The first way is, you know the pOH value already. Now you can just use the same strategy as we did for hydronium to find out the hydroxide concentration. Another way to find out the hydroxide concentration is, since you know the hydronium concentration, you can use this equation to calculate the hydroxide concentration. Let's use this equation. So hydroxide concentration equals to 10 to the negative 14. Oops, let me erase this. Okay, so equals to negative 14, 10 to the negative 14 over the hydronium concentration. So that equals to 10 to the negative 14 over 1.78 times 10 to the negative 5. That equals to 5.62. 5.62 times 10 to the negative 10 mole per liter. All right, this is how we find out the hydroxide concentration. Now, how do we decide whether it's acidic or basic solution? Take a look at the pH value. And the criteria is in this square. Since the pH value is less than 7, this is acidic condition, solution. All right, this is how we find out the pOH hydronium hydroxide concentrations if you know pH value. The second question, if you know the hydroxide concentration, how do you find out the pOH hydronium concentration? and identify whether it's acidic or basic solution. Now, you know the concentration of hydronium. The first thing that you can do is to calculate the pOH value. So, pOH value equals to negative logarithm of 8.7 times 10 to the negative 7 mole per liter. Okay, that gives me 6.06. So this is a pOH value. After you find out pOH value, then it's going to be very easy for you to find out the pH value, because pH value equals to 14 minus 6.06. And that is 7.94. Alright, now here is very easy because you know the pH value. You can calculate the hydronium concentration by using the same strategy we have for the first question. Or if you know, you've already know the hydroxide concentration, so hydronium concentration would be 10 to the negative 14 over 10 to the negative 14 over the hydroxide concentration, 8.6 times 10 to the negative 7 mole per liter. Okay, so the answer is 1.15 times 10 to the negative 8 mole per liter. The last question, is this acidic or basic? You take a look at the pH value again. Since it's greater than 7, so it's basic. Alright, I hope this video can, again, make you understand this calculation, the concept a little bit better. And again, if you have any questions, please let me know.